Hello, students. This is assignment 2.8, the demographic transition model. So for this assignment, I want you to use the Screencastify that you're watching on Google Classroom to complete all parts of this assignment. Take notes on the Jamboard that's also on Google Classroom, which everyone has their own copy of, and use the text box option to take those notes. And that's just this little T box right there. And you will also be using the drawing function as well to draw out each part of the demographic transition model, which you'll see abbreviated as DTM, and then to draw out the entire DTM as a whole graph. And this is that little draw function right there that you can find on Jamboard. So we're going to go over a few terms that we've already talked about or that you have already looked at because they're really important to understand the demographic transition model. So first one is crude birth rate, which is CBR. And that is the total number of live births in a year for every 1,000 people alive in society. The DTM also deals with the crude death rate, which is CDR, which is the total number of deaths for every 1,000 people alive. And the last thing is the natural increase rate, or NIR, which is the percentage by which a population grows in a year. So to find that, you would subtract the CDR from the CBR and then divide by 10, and that does exclude migration. So we're looking for the natural increase rate by births versus deaths, not dealing with migration. We'll talk about that later on. Folks, I'm going to just continue. Remember that you can pause and go back to any point of the video if I am going too fast. So what we see here is just kind of a simplistic version of the demographic transition model for the most part. So here we see population increases when birth rates are more than the death rates. We see a population increase. So if the birth rates outweigh the death rate, we see a population increase. Population is steady when birth rate and death rate are the same. So population stays the same when they are equal. And then we see a population decrease when death rate is more than the birth rate, population decreases. So, right, the death rate outweighs birth rate. So that's when we see a decrease. And that is what really, in a nutshell, the demographic transition model shows us. Now we're going to look at each part of the demographic transition model in detail. That you will have to take notes on this stuff. So stage one. So for this stage, or for these next 5 slides, folks, I do want you to write down the words that you see here, the information, and then also draw a sketch of the demographic transition model that you see right here. Just really rough sketch. Doesn't have to be a work of art or anything like that, but just to give you an idea of what's going on. And I would like you to label, if you see a label, if you see a label here, you can put those on your sketch as well. So the green line is going to be the death rate. The blue line is going to be the total population. And the yellow line up here is the birth rate. So stage one sees high birth rates and high death rates. The total population is very low as births are canceled out by deaths. So that is stage one. And we'll talk, and you're going to be looking at more why this is happening at the end of your assignment here. Right now, we're just getting some general information. Stage two sees a continued high birth rate, and that's the yellow line right here. However, we do see a decline in the death rate in stage two, actually pretty dramatic decline of stage two right here with this green line of the death rate. And this leads to a steady increase in population and a positive natural increase rate. So we have the blue line here that is the population increase, and a positive natural increase rate, meaning that we see more people being born in a population in a year. Stage 3 sees a decline in birth rate, which this yellow line is right here. Death rates decline even more in stage 2, but they're starting to level out a little bit here. And population continues to rise due to decreasing death rates. And that's this blue line right here. We can see it's not as sharp of an increase as it was in stage 2. Stage 4 sees birth rates decline even further. So this yellow line, almost to the point of flattening out completely. Death rates decline to the point of being almost equal with birth rates. That's again that green line. And population does continue to increase, but begins to level off at the end of stage 4 here. And stage 5. So there are very few countries in stage 5. So much of this is hypothesis or guesswork. However, what we can observe from countries who are in stage 5 is the following. We see a negative birth rate, meaning people are not having children whatsoever, and a steady but low death rate. So it's still people are still dying, but it's really almost flat. There really is no increase, nor is there a decrease. And we see a declining population, which is indicated by the natural decrease rate here in gray. So if you have people having less children, the same amount of people dying, that is going to lead to a decrease in population. So folks, just to reiterate, what you should have done for these last 5 slides is have written down all of the information on each slide and drawn a very rough sketch of each stage, just kind of off to the right or wherever you had room on your Jamboard slide. If you did not do that, please go back and do that at this time. So where has the world's population increased? So we see population increases rapidly in places where many more people are born than die. Like Kenya has a 2.4% population increase, and India has a 1.5% natural increase rate. It increases slowly in places where the number of births exceed the number of deaths by only a small margin. So the United States only has a 0.4% increase rate. And it declines in places where deaths outnumber births. So like Japan has a negative 0.2% increase rate, or you could say a 0.2% natural decrease rate. Okay, so what you should do right now is on the next slide of your Jamboard, and I'm just clicking through right now to make sure I'm telling you the right slide number. On slide number 9 of your Jamboard, please draw out the entire demographic transition model using your notes. So instead of it being broken up into chunks, I want you to draw out the entire demographic transition model as one big chart. Please do that right now. On the next slide of your Jamboard, on slide number 10, it says population pyramids of the DTM. Draw what each stage's population pyramid would look like at each stage. So that's what this slide right here on the screencastify that you're looking at is showing you. So population pyramids of the demographic transition model, stage 1 looks like this. right? A high birth rate. That's what the bottom here indicates. High birth rate, lots of babies being born. And then a rapid fall in each upward age group due to high death rates and a short life expectancy. So there are very few people reaching the age of 65. There are still even very few people reaching the age of like 30. Most of the people are going to be in this ages from about 15 to 29. That's where your highest population is going to be. The next stage, stage 2, is also expanding. So we still have a high birth rate, but a fall in death rate as more people are living to middle age. And there's also a slightly longer life expectancy. So you can still see the birth rate is almost the same here if you look at both stage 1 and stage 2. But instead of it being a sharp increase up, it's more of a gradual increase. So it looks actually more like a pyramid. That's showing us that more people are living to this middle age, and actually more people are living to older age as well. Stage 3 is stationary growth. So we have a declining birth rate, a low death rate, and more people living to old age. So in stage 3, you're seeing a lower birth rate. So it's really kind of gradual or lower percentage of births. And then more people are living to older age. So there is a higher life expectancy. There's more people in this middle-aged group, and there's more people in this older age group above 65. And then stage 4 is actually a contracting population growth. So there is a lower birth rate. You can see that kind of it goes in right here instead of it being kind of uniform. Higher dependency ratio, which we'll talk about, and a longer life expectancy. So there is even much more older people than there was in stage 3. So that is what each population pyramid of the demographic transition model looks like. We'll talk about the 5th stage, so don't worry about having to draw anything for that right now. All I want you to sketch is each of these 4. So that's what you should be drawing on Jamboard slide 10. Okay. The last slide of your Jamboard assignment is what is happening at each stage to influence population growth or decline. So this is something that you're going to have to kind of look at yourself. And I have a resource that you can use so you don't have to just find it on your own. So using the link on Google Classroom, you will find an article titled, "What is the Demographic Transition Model?" You do not have to read the whole article. You can if you would like to, but the portion of the article that you must read in order to complete the chart on slide, I think I have that incorrect. Yes, it's slide 11. I'm sorry, it's slide 11 on the Jamboard in the section titled, "What are the stages of the demographic transition model?" So again, folks, that's Jamboard slide 11. So read the section and answer this question for each stage. What is happening in society to help explain what is happening at this stage of the demographic transition model? So you do have to do it for all 5 stages. The link and that section of the article will give you some ideas of what is happening in society to help explain the stage of the demographic transition model. And all you have to do